Oh, look at this. Everybody's just super excited.
Excellent, okay.
And so before we had the problems, Patrick was telling us about how 3D Systems is kind of what started most of this back in the 80s.
It started all of it. It started all of it, yeah.
All of it with SLA printing,
so 3D Systems is the founding company. So Chuck Hall invented three-dimensional printing around about 1983 and formed a company around about 1986. And then we brought our first 3D printers to the Detroit Auto Show in 1989.
Wait, the first 3D printers?
First 3D printers.
Detroit Auto Show.
Yeah, and there was two Sterlithography machines were acquired by one of the automotive primes in Detroit, specifically for rapid prototyping. And that's
I see.
and that's the very beginning of the 3D printing industry, essentially. Yeah.
So it started with rapid prototyping, and those first two machines, I would imagine they look nothing like what these machines today look like.
Do you know what Sterlithography is? It's an oldie but a goodie, right?
Sure.
It still accounts for...
We're talking about the laser with the galvanometer?
Ultraviolet laser and photopolymers. It still accounts for around about 90 to 95% of all 3D printed objects on a daily basis are coming through Sterlithography systems.
Now I know we're at an industrial professional show,
Yeah.
so are those numbers based on big business and industrial use?
It's a mix. I mean, the vast bulk of it is mass custom manufacturing. So if you look at aligners, for example, Invisaligners, it's a mass custom manufacturing workflow. 300,000, 400,000, 500,000 unique plastic objects being produced on a daily basis.
Okay.
And that's utilizing the Sterlithography, utilizing Sterlithography technology,
right.
And it's a mass custom manufacturing of disposable thermoform tooling workflow. So you're
thermoform tooling,
yes.
meaning?
So you're 3D printing little dental arches, and then they are custom based on a patient, and there's multiple iterations based on a patient because you have to incrementally move the teeth.
Right.
And then they are tooling essentially for thermoforming medical grade sheet thermoplastics for creating the aligners.
Oh, I see. Okay.
And that's one of the largest what we call mass custom manufacturing workflows in existence.
Well, it makes sense for the dental industry because before a lot of it was handmade almost, right?
Yeah, I mean, clear aligners did not really exist until 3D printing existed. So it's actually a workflow that was enabled by the invention of three-dimensional printing.
That makes a lot more sense. Because what
or
they
at least
had to do before,
economically, yeah.
So then the 3D printing has allowed the liners essentially, which then mean, I would imagine, less braces for cases where aligners can fix, right?
It allows people to move their teeth discreetly, right? So now adults that have always wanted to move their teeth, that were, say, in an office environment that don't want to have, big braces that maybe they missed out when they were teenagers, are now able to basically accomplish the exact same thing, but in a discreet way.
That makes sense.
And as the technology continues to evolve, scanning technology, software, algorithms, the manufacturing process continues to evolve and optimize. We're getting to the point now where some of these aligner companies are actually able to do more than what even traditional aligners are able to do because they're able to control it in a digital way versus having an orthodontist make all these little adjustments.
Essentially we're at the part where computers, machine learning, AI can do the changes to teeth position at incredibly small levels for these liners to be able to take effect.
Yeah.
And now, 3D printing isn't just for the dental industry. I know that, right?
Mm-hmm.
I mean, and I'm sure you wouldn't have gotten involved in it if it was just liners for adults'
No,
teeth.
it's one of many applications. I always like to refer to the dental industry and the prosthetics that exist within the dental industry as the largest custom spare part manufacturing industry in the world.
Dental industry.
Yeah, you have 32 ceramic components in your mouth, and they wear out, and they're really important, and they're custom. And it's also the largest made-by-hand cottage industry in the world, and it was an industry that was ripe for transitioning from analog to digital.
A lot of people in the comments are saying that they know people that had Invisalign.
Yeah.
Mm-hmm.
Yeah, if you've had Invisalign, then you've had an aligner that was made via a 3D printing technology. So, okay.
Here's an interesting question, and I'm not sure you've been asked this before, but part of what I do is I try to inspire, especially kids or young people,
Yeah.
or people that may not be familiar with additive, to take part in the industry, hack and tinker and stuff like that. When you were a little kid, what were you interested in, and what do you think got you into this additive side?
My passion has always been, I'm a design engineer.
Oh, really?
And what caught my attention with how 3D printing caught my attention was, when I was learning CAD and this is back in the 1990s, designing something on a computer, and you're rotating it and you're looking at it, and if you wanted to make a prototype, I'd go to the model shop and I'd spend many days, if not weeks, carving and cutting foam and using all these kind of traditional methods to create a prototype.
As a designer, foam was your friend for the longest time.
It was like foam and MDF and different media, right? But then when 3D printing came along, just being able to go from something that was like digital and something that was virtual on a computer into a physical object in minutes to hours, it just blew my mind, right? It's something that you were kind of iterating with at a very high frequency. You were now able to convert into physical reality very, very rapidly. And the experience, when I experienced that for the first time, it put accelerant on the iteration process, right? Because when you're designing something, it's like you're having a conversation with a three-dimensional object. And when it takes a long time to get a signal response, a physical signal response, it's a very long-winded conversation, right? But when you're
Absolutely.
able to try something and then instantly get a signal response, it allows you to basically iterate at a very high frequency. And what that allows you to do is go from idea to final product a lot faster and ultimately get to a much better product. So that was a key kind of revolutionary aspect for me that really kind of caught my attention, and there's no going back from that.
No, not at all. And I like where you're coming from, the industrial professional side with 3D systems, but what you're talking about really echoes, I think, what's happening a lot on the consumer base with the maker movement.
Oh yeah,
and, people having all these digital fabrication things in their garages and maker spaces.
Yeah.
Do you have a 3D printer at home?
I do not have a 3D printer at
Really?
home. No, I'm so deep in 3D printing that I try to keep my my work and my
That's fair.
and my personal life separate at this point. But I work in a lab in Berkeley, California, and we have rooms filled with all kinds of different 3D printing technologies. And sometimes my kids like to design, and I print things for them. But I don't have a 3D printer at home. No.
Have your kids expressed an interest in this? Because you've been in the field?
Absolutely. Yeah. I mean, it's anybody who's in any way into making things or creating things or designing things or problem solving. Anybody who's got on the engineering spectrum or design spectrum in any way is again, it's the same thing, right? You're able to go from something which exists in just zeros and ones floating somewhere on a computer into something that exists as physical three-dimensional voxels. It's just mind-blowing, That's just the beginning, right?
That's right.
That's just the prototyping aspect. It's now when you take that experience and you take that and you start to apply it to problem solving, real problem solving.
Such as what you're thinking?
If you want to make a rocket engine that burns more efficiently, that can burn at higher pressure, if you want to make a jet engine that has turbine blades that are capable of operating in higher temperature environments, if you want to make, I'm not aware. I mean, every industry it has an impact, right? From medical, making spinal fusion cages that are lighter and better and integrate better with the body and heal faster.
What you're talking about here, I believe, is design for additive. Right?
Yeah, design for additive.
So then, how you came up in the 90s, obviously there wasn't that design for additive.
There was not. Yeah,
but
that's true.
Now there is, and so with your background, have you found it difficult to adapt, or has it been exciting and something that you're just trying to get more of?
Design for additive is fundamental, right? If you look at the fundamental value proposition of 3D printing is one, it's really fast. and that's where rapid
It can
prototype.
be.
That's where rapid prototype. It's really fast relative to subtractive
absolutely.
and formative methods, right? And second fundamental value proposition is that there's almost no correlation between cost and complexity. And what the technology allows you to do is to somewhat throw away the traditional rules of design for manufacture and design for what I call design for functionality. And that's a fundamental. That's actually the revolutionary aspect of the technology, is that now it's allows engineers at the very front line of problem solving, whether you're a propulsion engineer, aerospace engineer, you're designing brackets for satellites or spinal fusion cages or engine components for Formula One cars or aerodynamic components, is if you're the very, very front line of problem solving in any of these spaces, when you are now able to design with a new philosophy, a philosophy that is no longer constrained by the limits of traditional manufacturing, you are able to present step changes in performance. And that's the fundamental core capability that Additive presents, right?
Meaning step changes, meaning what do you mean exactly by step changes? Because I'm taking that as almost like a giant shift.
I mean that's so when you look at the three pillars of manufacturing: subtractive, formative, and additive. Additive is considered now a pillar of manufacturing, worthy of the title a revolutionary technology versus just an evolutionary technology.
I would agree with that.
Right, because it allows people to do things that were traditionally impossible. Right, so we talked about aligners earlier. Aligners. At that scale is just it's not technically feasible, it's not economically feasible in order to produce it, so it enables something, right?
Okay.
Being able to 3D print a perfect replica of a person's heart and give it to a surgeon, derived from an MRI or a CT of a blood model of a person's heart, where you can create a perfect replica in fine detail of the heart, build in a flexible, transparent, rubber-like material, give it to a surgeon and allow the surgeon to practice the surgery repeatedly over and over again, make all the mistakes that they would have made real time on a model heart, is absolutely 100% revolutionary from my perspective.
I completely agree. That makes a lot. Well, actually, we've got some parts off camera here that we can bring in, because part of what we're talking about here is being able to have incredible parts that couldn't be made in any other way, right?
Yeah, we do actually. So I can give you some examples here. So this is. We see a lot of application in structures, and this is a topology optimized bracket for a high performance automobile.
Okay.
And what's interesting about this is two things. One, it was designed automatically, so using a topology optimization algorithm, which basically uses FEA in order to drive the design and the distribution of material.
If I understand this correctly, within software, you're given constraints,
exactly,
and essentially some geometry, and then using FE, finite element analysis, right? And it's going to go through and remove parts of the geometry until it gets to a point where it still has the same strength properties, but it has less material.
It represents the first steps in the automation of design. So traditionally, this would require a person to iterate on,
right?
And it's very low frequency, right? Whereas these algorithms now are recursively looping simulation with optimization, essentially.
So then, in something like this, then you have a person who designs a part, and prototypically, you would have a person that would design a part, and the geometry would exist, and that part could be made using additive. But with something like this, using FEA and topology optimization, right? You can take that part and then bring it into this form.
Yeah.
But so with automation, are you saying rather than designing a part, all you need to do is give a machine some constraints?
Yeah, you give it an environment essentially, and you give it the object an objective. And it's kind of similar to how nature optimizes essentially, right? It iterates at a high frequency, and iterations that present some kind of tangible signal response with respect to like an increment of capability are reinforced, and then it just continues over and over and over again until essentially its optimization plateaus and it reaches close to perfect optimization. And what's really interesting about the outputs from these algorithms is that most of the time they're almost impossible to manufacture using traditional methods.
Right.
So
so
they're perfectly symbiotic with additive manufacturing technologies, right?
Yeah.
So,
I just it really blows my mind, and I think, well, I come from a lot of the consumer world.
Yeah.
You know, where we've heard of, and we do have some. I know some people that do use topology optimization in what was it, N topology?
Yep.
Or Fusion 360
Yep.
has finite element analysis.
Yeah.
But it's more of a wow, that's cool, rather than just a part of everyday life for many. And so.
Yeah.
And so for something like that, I feel like this is the future, and once more people get
I think so, yeah, and it's
right?
not just structures. You can also, like we're looking at electromagnetism, right? So collapsing electromagnetic fields in induction, like 3D printing stators for higher torque, higher performance.
Okay, that's just cool.
Yeah, and it's a fluidic flow. So if you're pumping, cryogenic fluids through manifolds for cooling, silicon wafer tooling equipment, for example, being able to model the fluid flow so that you absolutely minimize turbulence, you minimize vibrations in systems, which allows for less and less mechanical noise, which ultimately leads to higher and higher resolution microchips, right? So again, like I said, it's a revolutionary technology that's just like, it's a multi-dimensional technology.
It's just wonderful because I love that we have this amazing future to look forward to, right? Because everything that you've talked about is still almost infancy compared to where it's going to end up.
Absolutely. I mean, it's 3D printing is going to be around for additive manufacturing. It's going to be around for a long time. From my perspective, I believe that we're still at the apex. That we're if you look at the adoption curves of additive with industrial over the last 30 years, it's been a continuous incremental escalation in adoption, and it's compounded and accelerated by multiple factors, including new advancements in software enabling novel design architecture. It's also there's a lot of people growing up now that have grown up in a world where 3D printing has always existed.
Right, exactly.
I meet engineers all the time now that they don't look at 3D printing as being a novel technology. It's how you make things.
It's just how things are done.
Yeah, and it's how it should be things. In fact, what's interesting is that design for traditional manufacturing is actually harder than design for additive manufacturing. And the reason for that is that the rule book for traditional manufacturing is really thick. Yeah. It's like there's all these things that you shouldn't do and should do, and draft angles and web-to-wall ratios. And usually the more detail you add to an object, the more expensive it becomes, right? Whereas with design for additive manufacturing, there's a rule book, but it's a lot less, and you've got more freedom to really push the actual functionality and the capability and the optimization of the object. So,
that's cool. Yeah. You've got some other parts though. I do want to.
Yeah,
that one looks interesting.
Yeah.
And,
so this is an actual a high strength aluminum alloy. It's a scamalloy. Scamalloy is a high strength aluminum that we have certified for a lot of aerospace. If you look at satellites in space, taking a few kg, like taking 50% of the mass out of satellite brackets. Represents a significant cost saving,
time saving, materials. I mean,
we have over 1,000 brackets in orbit right now.
How cool is it to say that?
Yeah.
Like, I mean, how old are your kids?
I've got a 17-year-old, 14-year-old, and a 13-year-old.
Okay. I mean, they're still at least school age. I would imagine growing up, they got to say cool things to their class, like, oh yeah, my dad's company's got things in space. Oh, no, hey, guess what? They just put something in orbit. No.
Space. The space industry has embraced the technology because it's low volume and it's exceptionally high value, right? So, there is a relationship between the weight of what you're trying to put into orbit and the cost of putting it into orbit. Right. So, when you run a round of optimization on metal components, just bracket structures, then there's a tangible signal response with respect to value, and that's just the surface, right? When you really get into space, there's like incredible design architecture going on right now in fuel injection, nozzles, combustion, advanced cooling architectures where you are using the liquid methane in order to cool the combustion chambers and enabling remarkable capabilities in orbital lift.
Well, plus
So,
I've spoke to someone else who has done rocket and rocket engine design, and through additive they will have parts of this rocket engine that may have 1 to 200 pieces, and through additive it's reduced to like 4.
Yeah, more. I mean, I've seen examples of projects where the traditionally manufactured component was 3,500 components, and all assembled and brazed and welded and CNC'd, and you have hundreds of thousands of components, all requiring assembly, all the assembly lines and weld lines and braze lines requiring inspection, miles and miles of welds and brazes.
Like miles.
Miles, yeah.
Miles.
And that rocket nozzle, when it's designed for 3D printing, is one single component. It's a monolithic component. It's a CAD file. You can iterate.
It's a CAD file.
Your digital data. You can iterate on it like infinitely. You can. It's one of the core technologies that's enabling what we're seeing happening in the private space industry right now is the fact that you're not sinking costs into physical manufacturing and assembly, right? You were able to iterate on the CAD file, and you were able to produce those iterations by pressing a button on a three-dimensional printer, so that you can, over the course of 6 months, you could run through 5 or 6 different engines, and each one could be slightly different from the next. Each one could be an incremental improvement, essentially, and that's what's accelerating the innovation that we're taking place in reusability and rocket engines.
It's so cool.
It's remarkable technology.
I know we don't have a lot of time left, but you've got 2 more parts to get through, and then I have one more question.
This is also additive manufacturing is also reaching back in time, essentially, and touching traditional manufacturing, right? So if you look at injection molding tools, so this is an injection molding tool.
May I?
Yeah, and it's what's interesting. What's interesting about it? So this is a cutaway section, and just to show the interior. So the exterior just looks like a normal injection molding tool. It's made from a 789 certified tool steel. It's very hard, very tough, but it's got a cooling channel. So you see these little conformal cooling channels, and the cool thing about cooling channels, highly optimized.
Oh my gosh,
cooling
this
channels,
is heavy, isn't it?
Is that you're able to extract the heat more efficiently from the injection molding tool, which means that you can reduce the cycle time.
I was going to say, you go faster, right?
Yeah, so you can open and close, you can go faster, you can get like 50% more parts per hour out of your tooling. And you also reduce distortion of your plastic parts because you don't have areas that are hot, like you don't have hot spots and cold spots. You can normalize the thermal condition of the tool.
I was just going to say, you're not, like the heat isn't able to, it's not soaking in heat. You're sinking away the heat real quick, and it's not.
So you want the
deforming the part,
so you want to inject the plastic, and you want to be able to extract the heat as efficiently and as selectively as possible.
Selectively, that's key.
Exactly, and being able to drill bendy holes around corners and drill down to the hot spot and extract the heat from that hot spot means that you can now, your plastic is cooling quicker, so you can extract your parts at a higher rate.
That's
basically.
so cool.
Super interesting. Yeah.
I did just get the signal that you have to leave us.
Sure.
But real quick though,
Yeah.
there's a lot of information we covered, and is there a place where you would recommend people go if they want to learn more about 3D systems?
I would actually recommend, specifically for 3D systems, you can have a look at our webpage.
Okay.
Over the last year, we've done a lot of work making our webpage very design and engineering centric. So there's some good information there. And that's at 3dsystems.com.
I would imagine.
Yeah, absolutely. And there on the tabs, you can go look at advanced additive manufacturing and silicon wafer tooling applications, aerospace applications, medical applications.
Oh, there's a bunch of rabbit holes to dive down.
Radio, like we're doing, we're improving the fidelity and sensitivity of radar antennae, waveguides. There's a ton of information.
We got a lot to talk about the next time we get together.
Yeah, we can.
Thank you for joining me,
It's
Patrick.
A pleasure,
this has been awesome.
Thanks so much,
I
Joel.
really
Pleasure.
appreciate it.
Thank you so much.
Have a good rest of your rapid, man.
Cheers. Okay. Thank
care
you.
of yourself.
Okay. Thank you.
Hey, that was fun. Boy, that was a good time. I'm going to look at this chat here. Chat is on fire. Chat is on fire. Wow, that was a good time. I can give you one of those real quick. We're streaming right now, so
Can I take a picture with you real quick?
we can do it after the stream.
Sure.
Yeah, absolutely. Oh man, John Stern, Chad is on fire. No, not Chad, not Chad. Chat. There's a T there. Chat. That was Patrick Dunne from 3D Systems, and that was probably one of the most thrilling, exciting, wonderful, informative conversations I've ever had about additive manufacturing. I am so focused on consumer 3D printing with everything that I'm doing, and just to be able to have that deeper dive into the industrial and the professional side, just to be able to see someone who's in it day in and day out and having a lot of fun and leading the bleeding edge of this stuff. Oh man. Oh, hey Sean. RC Maniac 25. It was good. I'm really glad. I really hope everybody, I know obviously we did have some issues at the beginning, and I do apologize for that, but I think it's important to remember that we persevered and we got through it, and we ended up delivering one of the best conversations I've ever had, hands down. So that's kind of exciting. Tripod's Garage with $4.99. Are you out of your mind? First frosty beverage on me. I love you, dude. Oh, is our next guest is coming up? I need make sure I know. Hey, David, just make sure I have pronunciations correct, please.
Hotter.
Huh?
David. Hotter, like the weather. H-O-T-T.
David Hotter, like hot.
David, like
Hotter.
hotter. David Hotter, like hot but hotter.
Yes.
Yes. See, I'm David Hot. He's David Hotter.
I guess so. Okay.
And my wife is hottest.
And it's from Paratech.
Parmatech.
Parmatech, thank you. Okay, I remember I read that in my email.
Yep.
I was looking at your shirt, I'm like, wait a minute. So next up, the next guest on our stream from Rapid TCT 2021 is David Hotter from Parmatech. Hey, David.
Hey, Joel, how are you?
Hey! Thank you. Thank you for that. Hi, David.
How are you?
Hey, I'm great. It's good to meet you.
Yeah.
Thanks for coming on the show.
Absolutely. Glad to be here.
I like your shirt. I find that your sleeves are fantastic.
Oh.
I just want to say.
Awesome.
Just right off the bat. You do have a prop with you.
We do.
I've heard that we have some 3D printing going on with this putter.
I brought the first commercially available 3D printed golf club. This is the first
in
3D
production.
In production. This
So-
went out on a limited release
Okay.
last year, about a year ago in November. It sold out within 36 hours. So we made this for Cobra. So this entire head and hosel is 3D printed, 316 stainless. The face itself is an aluminum alloy. We did that for some of the machining technology and put the right surface on there so that it has a better feel and that the ball kind of works off of it
Oh yeah.
a little
hold it.
better.
So
Sorry.
Sean over there is going to get a really tight shot on that.
There you go.
That's a cool looking club.
Yes.
So I do need to be upfront. At one point, I did try to resin print a driver and
Okay.
a putter, and the driver we caught shattering into thousands of pieces at high speed. But the putter worked.
A resin
The
putter?
worked.
Okay.
On a resin because it's not.
Right.
I'm not.
It's not
hitting it.
structural,
It's
right.
not structural.
Exactly.
But that though,
I still use
that
the putter.
do you?
I still
oh
used it
So.
last week.
So David does golf and he used
Okay.
the putter. But this is much better. I'm going to be honest with you. This looks cool.
Pretty-
So 316,
316 stainless.
and then it was aluminum on.
And it has an aluminum face on it.
aluminum
The thick face,
okay.
yeah.
So then is that part of the additive process, or is that?
That's
additive?
not additive.
Okay.
That's
I was
additive.
getting-
Yeah,
it.
that's
okay.
addition.
When you hold it like so it's against your shirt area, just so it's, just like
Yeah.
in this range, like that kind of range, looks better against the blue.
Oh.
Hey, everybody.
Working through the bugs here.
King. Look at that.
There you go. Cool.
316 aluminum there.
Yep.
And then.
And then they
there's-
shaft it. They do the rest of,
I
the
would
part.
imagine that. So,
But you can see
muzzle there.
the
So
features
this right
here and the latticing. That's right.
That is. What is that?
So that's just This is all 316.
Oh, it's all?
It
Okay,
is.
okay.
We just do a PVD coating on that to turn it black. So that's more of a visual
You gotta make it
aesthetics.
look cool,
Exactly.
right?
But you see the latticing, you see how they took care of optimizing the weight distribution of the part.
Okay.
So that was the key to this project was how do you make a putter that still feels good, 3D printed, and move around the material so that it has good balance, good moment of inertia.
Yeah, because everybody, they love, I mean, putters
It's all
are a
right. This is
thing.
a field club, right? It's not a distance club. It's not a driver. It's not an iron where you need so much structural, but it's got to feel right.
Yeah,
It's
exactly.
Right. And we were able to achieve with 3D printing and the latticing, putting the weight where they wanted to. Now we went through over 50 iterations of this part.
50, so
50
well,
iterations.
we're
You're
talking
talking-
digital iterations.
Correct.
Right?
Which is why 3D printing really was a good fit for it, right? It took 57 tries or so to
Sure.
get to this model, to get to this.
And we were virtually like swinging the putter to putt a ball?
Well,
or?
we would give it to their pros, so we would give it to Cobra, and they would have it tested out.
Oh, okay.
By Bryson DeChambeau actually used this, and he helped design it.
Oh, that's
Yep.
fantastic.
Yeah.
So then, what part did you play in this?
Well, so we had to work with Cobra to basically optimize the design for the 3D printing process.
I see.
We use HP's metal jet technology, so we have their machines.
Okay.
Yep. And so we had to work with them to basically take their design and figure out a way to print it, and then to sinter it, and to get it dimensionally sound, and to scale that up from prototype up to full production.
How much? And you said limited run.
It was.
How many was it? You said?
There were over, I believe it was 300 or 500 that went out there to the market, something like that.
And they sold out quick.
But I think, or 1,500, I'm getting that stat.
That's okay.
You know, a little mixed up. But we have printed for production for other customers, production runs of 8,000 parts. So yeah, so this process is scalable. You start off at this level where you're doing prototypes, and you can scale up to full manufacturing production volumes very easily, very quickly, and cost effectively. So it's here. This is technology.
This is for Cobra, and this is
for Cobra, and we're working on the next version of this.
really
as
okay.
we
So
speak.
tell me more about that, because
Okay.
obviously this must be a success if you're working on V2.
It is. It is.
Or I
So
guess
version 2,
V57 or whatever
right,
it is, right?
50, yes, exactly. So that'll be out late next year, going into 2023. So there is a design cycle that we have to go through on that, and we're working on different designs with them. So they're kind of working through what do we want to test out, what do we want to iterate in designs and test, and how do we optimize it even further, and make a version 2 of it. So that's the industry. They're always looking for the next best.
So I'm not a golfer, but I understand the mechanics behind it.
Mm-hmm.
I played once and I was
Sure.
terrible. For a putter, like you said, it's a feel.
Yes,
right.
it is.
So can you? I don't know if this is. I hope this isn't a stupid question, but can someone come to you, and you take in certain constraints like how they swing and how hard they swing and where the balance is, and can you bring that into a design?
So we're talking about that because one of the benefits, an additional benefit of additive manufacturing, 3D printing with metals, is that you can get into the customization, mass customization. So that's one strategy that we are looking at for Cobra, for all of our customers, is how do you take the technology and apply it to the medical industry, to other applications that are asking for customization, but need it cost effectively. So down the road, we're working with Cobra, we're talking to them about that. Can we take a model, can we do it with other clubs, other club faces? Work with Loft and Lie, like actually optimize, customize for the masses.
Do you think additive eventually will make its way into the entire? Do you think an entire set of clubs could be
Absolutely.
3D printed?
Sure. I think it's possible.
Do you think it's already happened and no one's talked about it yet?
No, I don't know that it's out there yet. I haven't heard about it, so I mean, it could be. There could be some skunk works out there that's working on it, but there's a lot to be done. I mean, there's alloy development that has to be, optimized, worked on, and achieved, and then the club designs. There are differences when you compare to conventional manufacturing methods. You're unseating very proven technologies, casting,
Absolutely.
forging processes. So there's some work to be done, but I think we'll get there.
Oh, absolutely.
Yeah,
I think we'll get there.
I mean, we're already doing, this is powder-based process, right? So metal injection molded, Cobra actually does metal injection molded irons.
Metal injection molded. So is it molten metal injected
Not
in?
molten, but molded in the same machine that you do plastic injection molding.
I see.
Right.
Okay.
So
okay.
powdered metal injected through. Very similar, it goes through the same post-processing, so the sintering
Right.
processes and things. So it's out there. So powdered, processed, and manufactured clubs are there. Now we're just working on how do you 3D print them.
Makes sense.
Yeah.
So if, obviously, I mean, this is cool, and there's certain disciplines that you kind of have to be familiar with in order to get to this point. Part of what I do is I try to inspire those who want to get into additive, you know, kids, young adults,
Sure.
sometimes old adults. I've heard from lots of people who've
Yeah.
said, you know, they've gotten their first machine at home. How did you get started?
How did we as a company get started in it?
No, how
or
did
me
you
personally?
get started?
Oh my, well
you know,
my
what-
background, yeah.
What is your background?
My background's material science and
Oh,
engineering.
perfect.
Yeah,
Okay, so
yeah.
it really
So-
lends itself to additive,
It is.
doesn't it?
And I found myself in the aerospace industry for over 20 years. We are getting into aerospace applications with Parmatech now, but back then I was dealing with all the cool alloys, the Inconels, these super alloys that are out there, nickel-based super alloys, high temp stuff, and in applications for jet engines. And so I've been involved in forgings, castings, all the sort of competing technologies with
Well,
this,
the-
right? That we're on, that we're
classic
competing.
technologies, right?
Right, classic traditional methods.
Yeah.
And the ones, so from a technology standpoint, now you see that 3D printing is augmenting the way we think about design, right? So it doesn't necessarily, you heard this morning, Boeing talked about GE's application with the fuel nozzle. I worked for a company that forged those fuel nozzles back in the day. Now they're 3D printing them. So you see this transition. So from a technical standpoint, as a materials guy, I just love that story. I love the advancement, right? It's the passion for how are we applying new technology to traditional applications, to traditional part designs. It's fascinating, right?
So then, it's super fascinating, and I think this is why I'm going to ask you this next question. So, as a materials person,
Yes.
what does the next 5 years look like for materials science in additive? Because I know right now 316 is very popular, even
Sure.
in the home-based crowd, because
Sure.
we have BASF with their ultrafuse material
Yes.
that people can print on a Creality machine and then
Right.
send it away to be sintered.
Sure.
So we're starting to get the home makers and the tinkerers into metal 3D printing with what they know. So if we get in our TARDIS and we go 5 years in the future, what do you think it looks like?
Wow. There's a lot that I've heard talked about. I mean, first it's going to be, in the near term, it's making more alloys available for the process. Like you said, Joel, you've got 316, 17.4 that we're printing right now with HP system. There's a need. The market is using, in other, maybe not the binder jet technology, but others are doing the nickel-based alloys. They're doing the titaniums. It's alloy development I see as the future near term. How can we bring more alloys to all the additive metals processes, right? And make them available to any piece of equipment that's out there so that we're less limited in what we can print, okay? And then longer term, it's from our standpoint, from the powder-based processes, it's what you're doing with those powders. I've heard a lot of stuff, a lot of talks about how you may see like compound powders, right? So bimetal printing.
Okay.
I've heard that talked about, and it's how we compound, how we get different alloys in the mix, and optimize properties by alloying in a powder. It's fascinating. I don't know how it's going to be achieved. They're talking about doing it in different layers, maybe even
So
co-mixing.
bimetal via, well, right now, so within on the community sector, there's a company called Slice Engineering, and the heat break that exists in a 3D printer, they have a bimetal heat break.
Okay.
To be able to control heat dissipation
Sure.
and whether stuff that cool whatever. But apparently, it's a cool thing, and so it seems like bimetal or
Think about
multiple
composite
alloys.
applications where you're layering
Yeah.
dissimilar metals for some engineering purpose. Because at the end of the day, that's what we're trying to solve is the engineering challenge, right?
Right.
Somebody presents us with a challenge, and we have to take our not blinders off, but we just have to be very open-minded to the possibility of making any type of part with additive, to let ourselves free from the constraints that are self-imposed with just what we know, right?
Well,
with traditional methods, conventional methods.
It's a bit of that.
It's the mindset.
My previous guest was like, there are people alive today in additive who grew up and were born without ever not having additive,
Right.
and so where do you see? I see almost a hockey stick
Sure.
coming
Sure.
with kids and young people going through enough schooling
That's right.
that additive has always existed
Right.
for, that all of a sudden we'll have this almost this ready-made workforce entering in a number of years.
Yes, they're the future of our designers, our engineers, right? They are the future of it because they were born into it. they don't see the limits that we see in the other processes. They don't look at a part and say, that can't be machined. They just want to figure out a way to make it.
That's right.
Right? So they are the future. It's right. And it's talked about a lot that letting go of the conventional, kind of your conventional wisdom, your thoughts, you only constrain yourself with how you see a design, how you approach a part.
I love thinking that way.
Yeah.
Oh, that's so amazing.
It's awesome.
Do you have any 3D printers at home? I mean, are you a
I do not.
None?
Now, my
Like
nephew
zero?
does. I have a nephew who has one, so I can get parts made when I need them.
you go to your nephew and you're like, hey, I need some parts.
Just send him the file. He's got it done after that.
He's got it done. How old's your nephew?
He is 12 years old.
12 years old.
Yep.
So your nephew, I'm not trying to put you down, but he might
Sure.
be ahead of you.
Oh, he definitely is ahead of me. He's out there finding models of stuff to print all the time. Fascinating, the stuff they make.
I find it amazing that you're here at this incredible show,
Yep.
millions of dollars worth of machinery and materials,
Oh, yeah.
and showing me an incredible product that your company helped make a reality for Cobra.
Yes.
And you have to call your nephew to get something made. I don't know. I find that fascinating. So then, just to continue on this a little bit, obviously, I would imagine at one point, were you an inspiration to your nephew?
Oh, it's a good question. Yes, when you talk about when they learn, and anyone that I talk to hears about what we're doing, it's just cool. There's a cool factor, right? Additive
It's super
it's
cool.
huge. And to think that he gets this printer for Christmas, it was like, we didn't have anything close to that kind of technology at that age, right? It wasn't accessible to the masses that way. And now we are. Now there is. You can buy that. There's so many home users of these things. And there's models out there for anything that you want to make. You know, it's just, so inspiration, yeah, I think so. Just because we brought it to them. We made it more reachable.
Well, yeah,
the technology.
I think that the professional side of additive has brought about enough. I want to say they democratized enough in order for the consumer base to pick up on
Right.
it, provided at a lower cost.
Yes.
Put it
Yeah.
in someone's garage.
And that's the key.
What do you think from the professional side or the industrial side,
Okay.
what do you think needs to be brought down into consumer level to inspire more people to take this up? Do you think, because I'm printing in metals, I know we could kind of do it, on the consumer side, but we don't have a metal jet machine. We don't have.
Well, yeah,
those
it's
sort
a
of
cost
things.
play because it's even we promote it, like we do prototyping work, but our end game is to scale that to production.
Okay.
Because to be cost competitive, it's not a really cost viable prototyping method. You can do that. There are others doing it, but for the long play, you want it to be a production process because the metals are expensive.
And
the
they're
bottom
dangerous
line.
too. Like someone
Right,
in
and
chat
there's
just mentioned
volatiles,
that.
yes.
I know that we visited Siemens in Görlitz. Görlitz. There we go. It was in Germany for Formax. But we visited them, and it's the metal 3D printing room where
Yes.
they have all the machines. It's
yes.
almost like a clean room.
It is. It has to be. Yes. The volatile alloys, the titaniums, the aluminums. Yes. Very
'Cause
dangerous.
If they
So you have to contain those
powder,
powders. They're
right.
volatile. Yes.
Okay.
Yes.
Has there?
So
have you ever-
that will sort of prevent it from ever getting to a consumer level. I don't know that you're going to put a clean room or
I could imagine with Form has
explosion-proof.
their SLS, which you can do like PA12, right? I mean nylons.
Right.
Nylons, I think, are. Correct me if I'm wrong. They are a safer powder bed material because they won't
Yes.
bloom and catch fire.
Right.
Do you think we will see in the next 5 years nylon powder bed machines coming to consumers?
It's a good question. I think it's possible. I mean, anything is possible.
Anything's sure,
But I think
anything's possible.
in 5 years, the way that this technology is growing and expanding and it's exponentially advancing, I think that's probably a reality. I'd bet on it.
Yeah, okay. I
bet
think it's
on
safe. I think it's safe.
Yeah.
Because I would love to see more people, because like this, what you've shown me here, I imagine someone being able to do a prototype of this in a nylon at home.
Sure.
I know we can resin print these, and I know even FDM print these. I mean,
Yes.
I showcase all sorts of machines that could make this general shape.
Yeah.
But on the side of production and prototyping, I mean,
Like a functional prototype.
your nephew at 12 with what he's able to do. Once he's like 18,
Yeah.
20 years old, once if he chooses to go through college, like imagine how ready he's going to be for
He's
the
absolutely
world.
ready, right. You don't have to teach him the equipment, the thought process. You just have to give him access to it. Access to the materials, access to the equipment, the better equipment, right?
Well, does Parmatech offer any sort of internships or,
Yes.
or sponsor any sort of programs? For
We do.
kids to be
So
able
we
to
do
learn?
internships, we do summer interns, and we're always looking to hire young engineers. So we're growing, right? And we have 3 machines in our plant right now. We have plans to get that to a dozen machines in short term. So as soon as we
Short
can,
term.
this is short
Short
term.
term.
I'm talking 2 to 3 years. It's with a few production applications. That's a simple reality. It's very viable.
It's so cool.
Yeah.
What's the coolest thing that you have seen 3D printed in metal?
Ooh.
I mean, this is cool. It's cool because it provides that function, but the putter itself, it looks cool.
Yes.
And it has a really great weight to it.
Yes, yes.
It
Well,
does. It feels like a product.
Right.
But is there anything cooler that you've seen?
Cooler. Well, I mean, I think
Cooler, you know?
I really respect and appreciate the fuel nozzles that GE did.
Okay.
Because I know.
Have you seen them?
Yeah, yes. And
Oh.
and I know how those were traditionally made. I mean, we forged components that were put in there that were used for that, like the individual components that they consolidated into one print. So it's fascinating to know how that was forged, how it was machined, the details in that, and then to see that in application. I just think that to me is fascinating because it's a real part on a real engine that people are sitting on a plane, right? And to think that they were able to unseat or at least transition into a new design using new technology, that's not easy. Those industries, there's a lot of testing that has to be done, and
Lots.
qualification. So it's amazing. It's just, so that's an impressive application to me.
Oh, it's really
And it hits
impressive,
home for
right?
me, yeah.
Well, and obviously they've gone through the testing and the qualifications
Mm-hmm.
in order to use additive produced parts for it.
Sure.
And I know we're getting there in the airline industry
Mm-hmm.
with brackets, but do you think our future holds? Do you think our future holds additive airplanes? Do you think we will see more additive in the aerospace industry
Absolutely.
than what we have now?
Oh, for sure, for sure. They're an early adopter, and they've just scratched the surface, for sure. It's all about qualifying the materials, getting engineers thinking that way. I mean, with a lot of the parts and customers and potential applications that we review, we're looking at traditional designs and then trying to get or allow those customers to use 3D printing to make something new. But the best way to approach it is like this, with something that was never made before. It's not taking the existing design. That's good. We can certainly drive costs out of an existing design, but you want to start the design process with 3D printing in mind. So you think about how can that be done in aerospace, they are looking at it, right? Any engineer, newer engineers, you talked about the youth, with their approach of saying, don't think about this as a two-piece design. Don't think about this as machine. I just need some features. I need more than just features. I need function. I need performance. How can I get there?
Yeah.
And it's limitless. It's limitless with 3D printing.
For the design, though, because we've talked about qualifying parts, and I like what you said because it's not that airlines are going to start picking parts to replace. What they're going to do using design for additive is
Yes.
multiple parts that could be replaced with a
Yes.
single part.
And you need to be on, at the beginning of that, the infancy, right?
Yeah.
The beginnings, inception of a new design, of a new product. That's when I think you'll see a lot more applications applying the technology, is when they have a chance, because there's a lot of work. Requalifying an existing design is not optimal, right? So you want to start with it that way. You don't want to go back to something that was done that's a 10-year-old design and say, let's optimize that for 3D printing.
right.
You want to start with that in mind. It's a lot easier path, right?
Makes sense.
Yeah.
For this, obviously, this has to mimic a design, right? I mean, there's
Yes.
a general rule for
There is,
putters,
right,
right? You can't
right.
have this big.
There's an
bulbous-
envelope, yes, exactly.
It looks that way, and so for something like this, if I were to take a cross section of this, does the metal, does the properties of the metal look the same as a forged piece?
Well, it won't be, it's close to raw properties, but it will not be as close to forged, but it'll be very close to, or it'll be the same as what you get out of metal injection molding.
Okay.
So
I
you're,
see what
you're
you're saying.
densifying that powder, but we're meeting the standards. We test to the existing MIM standards that are out there.
MIM stamp, define
Metal
that.
injection molding,
MPIF.
MPIF.
There's all sorts of
Yes.
3-letter acronyms,
Yes.
right?
So there's industry standards for those powdered metal processing, and we meet those today. So you're getting almost fully dense, almost to raw properties. It's better than a casting in a property, and it is homogeneous across it, right? So you're getting good properties throughout all the print bed itself. So in our print box, in the build box, you're getting we can fit 24 of these in one print cycle in the HP equipment, yes. So one run, and you'll get uniform properties across that. So that's key to it as well. Because when you talk about scaling something, a prototype, you can make one off and you can optimize that. But when you look at the demanding applications in aerospace, in sporting goods, in medical, we need consistent properties across a whole production run. Right. And that we can achieve today. So that's why we're pushing for those scale productions. That's how you're going to optimize and bring that cost down. You have to bring the value into it, right? We just can't sell something that's unapproachable.
No, not at all. And I think scale is a giant limiting factor because it's that consistency over time that people have to get to with additive in order to be a qualified part. And so on the consumer side, we look at people who have Etsy shops, and while scale isn't necessarily a huge issue, they still worry about that and having to provide a lot of the same thing,
right?
Reprinting over and over. And so it's just interesting to see that on the consumer side, we see the problem of scale that people have to mitigate and solve. But as you get into the professional and the industrial side of things, there is still that concept of scale that has to be solved.
It does. And it doesn't have to be, when you talk about mass production of it, when you think about the mass customization, it can still be a little bespoke, but yet mass produced, right? That's one of the other features of printing is you're not investing in that tooling. You can be customized, but if you fill the equipment with parts, if you fill production runs and optimize that material and optimize the equipment processing time, then you get the value. So there's a balance there.
This has been an absolutely wonderful conversation, David.
I've enjoyed
I'm just
Joel.
so thankful you were able to join us.
Absolutely.
And I hope in the future we can kind of work together on something awesome because this is just scratching the surface. And I really, really think that 3D printed golf clubs need to appear on the channel, but maybe a little bit stronger. And maybe Parmatech can help.
Yeah, absolutely.
Hey, have a good rest of Rapid, David.
Joel,
I really
thank
appreciate
you so
it,
much.
man. Take care
Enjoyed
of yourself.
it. Thank you.
Awesome. So you got a couple minutes now to hang out with your friends?
Oh, sure. Well, I was just going to let him know. That was David Hodder, not David Hottest. Sorry, David. That was David Hodder with Parmatech. And what we got to see was a Cobra putter that was 3D printed. So cool. So cool. Well, hey, you know what? I have a few minutes. Let's hang out in the chat. What do you guys want to know about the show? What are you guys excited for me to show off? I'm going to take a drink of water because hydration is important. And then I think we just have a little chat. What do you say? Chris Gulata, 4. It makes sense. DIM, great interview. Pile and Bones, another awesome interview. RC Maniac, really enjoyed that. Tripods Garage, great interview. I'm really, really thankful that I have you all in the audience here along for the ride because these people that I'm talking to, Patrick from 3D Systems, David from Parmatech, these are the people that are living professional and industrial additive manufacturing day in and day out. These are the people that are pushing the future forward. These are the people that are responsible for hiring the people that come up from school and are ready to get jobs in this industry. And I think, honestly, something like that, it's just really, really exciting to think about. And to have people such as David and Patrick who have this passion for additive at the professional side, it's just, I know our future's looking really good. I have a perma smile on my face. I'm really excited about this. Phenomenal Printing 6, where is your energy drink? Oh, that's a really good question. I left it in the hotel room. I picked up a Bang energy drink at the market here at this hotel. It was $5, which is really unfortunate, but you know, sometimes you have to pay a little bit more when you need something just right then and there. And it tastes like bubble gum. So that's not a drink that I can slam. Bubble gum takes its time. And so by the time I went to bed last night, there was still half a can of this bubblegum energy drink on the counter. So, I don't know. I'm going to find myself maybe a sugar-free Red Bull. I know it's classic, but, you know, I think that'd be okay. Keebler 137 with a fiver. That's a high five. Fiver for high fives. Shane James from Jamaica. Oh, wow, Jamaica in the house. That's incredible. I love that through the magic of the internet, what we're able to do is bring a little bit of this rapid TCT show to you in your home. And so this 2021 show, it's exciting. I know not everybody can make it, and I'm really excited for the future shows, which means I get to bring to you more. I would imagine it's a little bit difficult to get here from Jamaica, but maybe it'll be easier in the future. Maybe there will be a 3D printed way for you to get from Jamaica to the show. Joey Salacho, sintered titanium still blows my mind. I agree. Let me take a sip here. Growing up, and let me know if you were like this as well. Growing up, I always thought titanium was like that end game sort of metal. And I obviously, as a kid, I didn't know about all sorts of different alloys and metals, but I always thought titanium was like one of the hardest, strongest metals ever. And it was just the first time I heard that we could do powdered titanium for sintering, for 3D printing, it blew my mind. It absolutely blew my mind, because I was like, here's this metal that I thought was unbreakable. And yet here we are in powdered form making 3D shapes out of it. It just blows my mind. Simon A. Joe, do you not like coffee? I do like coffee, but there is a time and place for everything. And the time and place for coffee was not right now, nor was it last night. Pile and Bones, you need your 3D printed frosty beverage holder. Oh, I would agree. I think that'd be a lot of fun. John Stern, I'm interested in printing ceramics. I think ceramic 3D printing is one of those things that's just incredible to see. And I'm willing to bet there are some machines here that can do it. And in fact, it was at Rapid TCT 2019, I spoke to Dror from XJet, because they did 3D printing ceramics at an incredible resolution. And so if you're interested in 3D printed ceramics, I would hit up XJet. Remember when chromoly was the only thing for BMX bikes? Wow. We're old, Chris. Terrence Shepard, with everybody having an FDM or SLA printer, are people really going to think additive? Terrence, that's a really good question. And that's part of the reason I love doing what I'm doing. Every once in a while, you hear from someone who says 3D printing is dead. And you know that they're talking about consumer printing, and you know they're wrong, and you know they're only considering like an Ender 3. It's crazy. It will blow your mind, the number of industries that utilize additive manufacturing to make things faster, to make them stronger, to make them cost less. And for something like that, additive is key, and additive will continue to be key. Plus, additive is going to be the way that we as a species can leave the Earth and explore other worlds, because I guarantee you, on a bunch of rockets, we're not shipping a Home Depot to the moon so we can build a bunch of houses. We're going to have to utilize what's on the moon and add to it in order to build these structures. And the way to do that is, you guessed it, 3D printing. Boy, that was really inspirational right there. Jeez. Andrew Rogers with a fiver. We'll wrap after this.
No,
Keep going? Oh, well, sure. Andrew Rogers with a fiver. There were some super chats at the very beginning of the stream. I know you were busy, and there were some glitches. For everybody that went through and was able to give some super chats during well, first, Andrew, thanks for the five. It's a high five to you. I know we had our issues at the beginning, but it's important to remember that you have to persevere. You can't get upset, and you can't let your emotions get the best of you, and you have to just remember that you can find the solution to this. And David and Sean and I were trying everything in our power, and we eventually made all the ones and zeros behave, and we got ourselves 2 incredible interviews. And so while we did have adversity at the beginning, part of what's important is being able to stick through it and just know that you're going to find that successful end. And really that relates to a lot of prototyping and additive, if I could bring it that way, because a lot of times, like what my guests were saying in the before time, classic ways of doing things was foam and MDF and glues and tapes and just being able to build stuff out of materials that you can shape with your hands, whether through cutting or gluing or taping. And so now with additive, we're able to iterate functional prototypes really quickly. And so while you may design something and it might fail and you might get stuck, don't just keep your head in the game and just know that eventually you're going to find a way to either fix it or do it better. I can't tell you how many times I have been designing something late at night and I get frustrated, and I know at this point, I know there's a point where it's really late and I get frustrated and I have to just hit save and go to bed. And then I wake up the next morning, I eat my Wheaties, and then I go to my computer and I know that all of a sudden my brain is in a different phase, and I can comprehend the problem better, and I know how to do the solution really quickly. Boy, that was exciting. You know what? Listen, we've got another live stream planned for tomorrow, same time. And what's great is we've worked out all of the kinks. And so it means, fingers crossed, that we're just going to come here and we're going to have some great conversations tomorrow. I didn't say it. I didn't say it.
Awesome guest.
And we're going to have some, we have some incredible guests planned for tomorrow as well. Just have your waters, your drinks, your beverages handy. And I look forward to seeing you tomorrow at the same time from Rapid TCT 2021. So if you've made it this far, you're awesome. Don't forget to hug each other more, print all the things. And as always, high five.